Yes.
Hello, everyone. Hello, Professor Jonathan. I hope you're doing great today. My name is Maria Camila Restrepo Maldonado, as you already know. I am a student of the program Biomedical Engineering or Bioengineering at the Universidad de Antioquia. I am at the 8th level at the moment, and with my partner, we're going to do this presentation about SPLD GAL devices.
Okay. Hello, everyone. My name is Daniel Basto. In the 8th level also. This presentation is for the subject for programmable devices of the program of bioengineering of Universidad de Antioquia. Okay, we're going to talk about GAL devices, but first of all, we have to talk about SPLD, and we have to talk about PLD before SPLD actually. So, what a PLD is? A PLD means programmable logic device, and this is a type or of a kind of embedded system. It was created in order to replace the wired logic because this logic had many errors. These kind of devices has many components such gates and flip-flops and etc. A PLD is different from a microcontroller and it is more related to a configurable hardware, you know. It's programmed by blowing fuses. SPLD stands for simple programmable logic devices. Okay. Before talking GAL, we're going to talk quickly about PROM and a PAL. A PROM is a programmable read-only memory, and a PAL is a programmable array logic. In PAL, the AND gates are programmable and the OR gates are fixed. The opposite happens in the PROM because the OR gates are programmable and the AND gates are fixed. In this case, in PAL, these kind of devices are not erasable. The design of these devices are really simple. They are really easy to program and they are highly efficient, you know?
Okay, now we're going to talk about the GAL devices. GAL stands for Generic Array Logic. It is an improvement of a PAL device. It is based on CMOS technology for making all the programming. Also contains hundreds of logic gates, ANDs, and ORs. And as mentioned in class, a GAL can be also known as a PAL plus a OLMC, which stands for Output Logical Macro Cells. Later on, we're going to see what this is.
Okay. What is OLMC? As Camila was mentioned, this is an output logic macro cell. You know, the main components of OLMC are gates and OR and flip-flops type D. You know, OLMC works in two different ways. One of them is a registered way, and the other is a combinational way. In the register way is it basically works with flip-flops type D, you know, and we can design states machines, you know.
Okay, so as my partner mentioned, the OLMC can work as a combinational way and a registered way. The combinational way works with flip-flops also, but this time they're going to be turned off. This can work more like a PEL, sorry, but this time they're going to be reprogrammable. Now we'll see how. We are going to see the advantages of these devices. As I mentioned before, they are reprogrammable, but how is this going to happen? How are we going to reprogram these devices? They are electrically erasable, which means that you can erase them with a voltage signal, and it can be reprogrammed over 100 times. It is made with erasable CMOS, as we mentioned before. Okay, also has microcell structures in the outputs and can do the logic function of the PEL devices. Okay, now we will see this example. I'm going to talk about the parts of it. Okay, so it has input terminals. As we can see, it has a total of 8 input terminals. Each one has a buffer, and the buffer leads to 2 complementary outputs to the AND array, as we can, well, it's internal. Now, the other part of it is the AND array, which consists of 8 inputs and 8 outputs. Each one leads to 2 complementary outputs in order to form 32 columns. Now, the output macro unit. This device in specific, the GAL A18B8, has a total of 8 output macro units corresponding to pins 12 to 19, respectively. Now, it has the system clock. The pin 1 of this GAL indices is the system clock input terminal, which is connected to a flip-flop type D. Yes. And now the output 3-state control terminal. The pin 11 of this GAL 16B8 is the common terminal of the 3-stage control of the device. Yes, go on.
In this last example, I will show you how to get this XOR gate. So which fuses should be activated and which not. In the case of the gate number 1, the fuses not A and C have to be activated. And in the case of the second gate, the fuses that should be activated should be the fuse A and not C. And well, this is all, and thank you so much for your attention.
Thank you, Jonathan. We hope you have a nice day.
Bye-bye.